Right now, within arm's reach of you, there is almost certainly a small gray magnet. It's in your earbuds. It's in the little motor that makes your phone buzz. It's in the speakers you're listening to me on right now. It weighs less than a paperclip, and in your entire life, you have never once thought about it. That magnet is made from a metal called neodymium. And here is the strange part, the part that started this entire investigation. 91% of the world's ability to turn that raw metal into that finished magnet sits inside the borders of a single country. Not 91% of the mines, which is the part everyone assumes when they first hear a number like this. 91% of the know-how, the refining, the finishing, the one specific industrial step that turns gray, unremarkable rock into the precise little object currently spinning quietly inside your pocket. And it isn't just your earbuds, which would already be a strange enough place to start this story. It's the wind turbine on the ridge outside town, each one needing roughly 2 tons of these magnets just to convert spinning blades into usable electricity. It's the electric car in your neighbor's driveway, and every hybrid built over the past 2 decades. It's the guidance systems inside modern fighter jets, which rely on these same magnets for targeting and flight control motors, in quantities defense analysts still argue about specifically but agree are substantial enough to matter strategically. So the question this video is going to answer is simple to state, and it should probably bother you more than it currently does. How did the most powerful economies on Earth, the United States, the countries of Europe, Japan, let one single country quietly take control of the materials sitting inside almost everything they build, sell, and defend themselves with? And why can't they simply take that control back? Here's the honest answer, and it's more interesting than a conspiracy. Nobody stole this. This is the story of how one country built an enormous industrial advantage over several decades. Through cheap labor, looser environmental rules, and a government willing to lose money for years to win a market, while the rest of the world, quite deliberately, kept choosing the cheaper option every single time it came up for a decision. The uncomfortable part, the part we'll get to properly, is that the West didn't lose these materials in any conventional sense. It handed them over, one closed refinery at a time. By the end of this video, you'll understand 3 things almost nobody explains correctly, even in otherwise serious coverage of this topic. Why these metals aren't actually rare at all, despite the name. Why that specific fact makes the whole situation more dangerous instead of less once you understand the real mechanism at play. And why, even now, even with governments finally spending real money, the West is still years away from turning this particular switch back off. This isn't a story with a single villain or a single stolen secret. It's a story about a decades-long accumulation of individually reasonable decisions that added up to something nobody fully intended. Let's start exactly where this story really begins. In the Mojave Desert, decades before anyone in Washington was paying attention. For most of the 20th century, if you wanted these metals, you went to California. Specifically, to a place in the Mojave Desert called Mountain Pass. From the mid-1960s until the early 1980s, Mountain Pass supplied roughly 70% of the entire world's rare earth consumption. America mined it, America refined it, America led, supplying the color televisions, the military lasers, and the early computing systems of an entire technological era. So the natural assumption, the one most people still carry, even people who work in adjacent industries, is that these are fundamentally American materials, or at least broadly Western ones, and that if we ever truly needed them again, we'd simply go dig them back up ourselves without much difficulty. Hold on to that assumption carefully. we're going to spend the rest of this video watching it fall apart, piece by piece. First, let's clear up the biggest myth because it's the key to everything. They're called rare earths. 17 elements with strange names: neodymium, dysprosium, terbium, praseodymium, europium, yttrium. The name makes them sound like some exotic treasure buried once in a mountain, the kind of thing you'd need a map and a shovel and a lot of luck to find. They are not rare, at least not by the standard geological definition geologists actually use. Some of them are more common in the Earth's crust than copper or lead, two metals nobody has ever described as scarce or precious. You are, almost literally, standing on them right now, wherever you happen to be sitting or walking as you listen to this. So if they're everywhere, what's the actual problem? The problem is that they never show up alone in any usable concentration. They come mixed together, in tiny amounts, bonded chemically into ordinary rock, and often bonded specifically with faintly radioactive material like thorium and uranium, which makes handling even the raw, unprocessed ore its own separate safety and regulatory hazard. To get just one single usable metal out of that mixture, you have to crush entire mountains of ore and run the resulting material through dozens, sometimes hundreds, of individual chemical separation steps, each one designed to coax one specific element away from its chemically similar neighbors. It is slow. It is genuinely toxic work. It produces lakes of acidic, radioactive waste that have to be stored somewhere, indefinitely, usually right next to wherever the refining actually happened, becoming someone's permanent environmental burden. Mining these metals is easy. Refining them is one of the dirtiest, most complicated industrial processes on the planet, involving hundreds of individual chemical stages just to separate one target element from the 16 others. It arrived bonded to underground. Remember that difference, mining versus refining, because the whole story turns on it, and almost everyone, including plenty of otherwise well-informed people, gets it backwards on first hearing. That toxicity isn't an abstract detail. It's exactly what started ending Mountain Pass's dominance, years before Chinese competition became the final blow. Between 1984 and 1998, the facility experienced roughly 60 separate leaks of radioactive and hazardous wastewater, totaling somewhere around 600,000 gallons, seeping into the surrounding desert. Regulatory pressure mounted, cleanup costs piled up, and in 2002, facing both those accumulated environmental problems and a wave of cheaper Chinese material flooding the market, Mountain Pass shut its doors. Here's a detail worth sitting with, because it complicates the story in a genuinely useful way rather than simplifying it into a neat conspiracy. Around this same period, back in 1992, China's leader Deng Xiaoping is reported to have said, during a stop in Baotou, Inner Mongolia, one of China's largest rare earth deposits, a sentence that sounds almost poetic in hindsight. The Middle East has oil, China has rare earths. It's tempting, looking back from today, to treat that single line as proof of some fully formed, deliberately executed 40-year master plan, and you'll find that dramatic version of the story told constantly across the internet, repeated in article after article without much scrutiny. But serious historians of the period, including scholars who study China's resource and industrial policy closely, caution against reading too much deliberate prophecy into a single quip made during a broader political tour that was, at the time, focused on entirely different domestic economic priorities. Treat the quote, honestly, as a rhetorical anchor rather than a smoking gun. A phrase that captures, in retrospect, an outcome that actually emerged from something considerably less dramatic and more explainable. Sustained, unglamorous industrial policy, a real and durable cost advantage, and 3 decades of Western companies and governments choosing, again and again, at every individual decision point, the cheaper option sitting directly in front of them. Here's how that cost advantage actually worked, and it's almost boringly simple once you see it. China had cheap labor, loose environmental rules, and a government willing to absorb losses for years to win a market permanently. Chinese refiners did something Western companies couldn't survive doing without going bankrupt. They sold these metals so cheaply for so long that refining them anywhere else stopped making basic economic sense. One by one, refineries in America, in Europe, in Japan closed. Each closure a small, individually reasonable business decision that added up to something enormous. Not because Western engineers forgot the chemistry, but because nobody wanted to keep running a toxic, money-losing chemical plant when China would happily do it for you and sell you the finished result at a steep discount year after year. And for a while, everyone was happy. The West got clean hands and cheap magnets. It offshored the pollution and kept the iPhones. That looked at the time like a genuinely great deal for everyone involved. By the 2000s, the transformation was nearly complete. Mountain Pass sat closed. Its eventual owner, Molycorp, which had tried and failed to revive the site with an expensive modernization push, filed for bankruptcy in June 2015, carrying roughly $1.4 billion in bond debt after prices collapsed under the weight of renewed Chinese competition. The West had stopped making the thing. It had only kept buying it. And that is exactly the moment a quiet dependence becomes a leash. It's worth sitting with how gradual this shift actually was, because gradual is precisely what made it so easy to miss while it was happening in real time. No single year looked alarming enough to prompt real action. No single closed refinery made front-page news anywhere in the world. It was a rounding error every year for 3 decades, and rounding errors, compounded patiently enough, eventually become the entire picture. The first time someone actually pulled that leash, hard enough for the whole world to feel it all at once, it wasn't even against America. It was against Japan. And it happened over a fishing boat. Evidência 2010. O dia em que a China desligou o Japão. September 2010. In the East China Sea, near a cluster of disputed islands, a Chinese fishing trawler collides with 2 Japanese Coast Guard ships attempting to intercept it. Japan arrests the captain and charges him under Japanese law. A small maritime incident, the kind that happens periodically in contested waters around the world. The kind of thing that normally ends with a diplomatic note, a quiet release, and a handshake within a few days, forgotten by everyone outside the 2 foreign ministries directly involved. Instead, something strange started happening at Japanese ports. Shipments of rare earths coming from China simply stopped clearing customs. No formal announcement. No official embargo. China denied there ever was one, and to this day maintains that nothing of the sort occurred. The metals just stopped arriving, container after container held up with no explanation offered and none requested. And Japan had a genuine, immediate problem on its hands, because at that exact moment, Japan depended on China for roughly 90% of its rare earth supply. These metals ran Japan's industrial crown jewels, its car industry, its consumer electronics sector, the precision magnets inside its most advanced and most profitable products. A country that had spent decades building a global reputation for the world's best hybrid vehicles suddenly couldn't be entirely sure it could reliably get the magnets needed to keep building them. The market understood the message instantly, even without a single official word being spoken. In the span of about a year, the prices of some of these metals soared by roughly 10 times. 10 times. Over a fishing boat and a captain nobody outside the two countries had ever heard of. Japan released the captain. But the real lesson wasn't about one captain. The world had just watched a live demonstration, broadcast in slow motion through commodity prices for anyone paying attention. China had shown that it could turn a commercial dependence into a foreign policy weapon without firing a shot, just by letting paperwork sit on a desk a little longer than usual. Everyone took notes. Washington took notes. Brussels took notes. Analysts wrote reports, some of them genuinely prescient about exactly what would happen if nothing changed. Committees held hearings, complete with expert witnesses laying out the risk in careful, measured language. And this is the maddening part, the part that makes this story worth telling at all. Almost nobody did anything meaningful about it for another decade and a half. The warnings were accurate. The response simply never arrived at the scale the warnings called for. Evidência 2. O que o Ocidente fez em vez disso? Nada. E de forma barata. You'd think 2010 would have triggered an urgent rush to rebuild Western refining capacity. It didn't. And to understand why, you have to understand the specific trap these metals set for any democratic government trying to respond rationally. Building a rare earth refinery from scratch is a 10-year project at minimum, sometimes considerably longer, once permitting delays are factored into the timeline. It's expensive, often running past $1 billion in total investment before a single usable ounce of finished metal comes out the other end. It's toxic, so nearby communities fight it in court and at town halls, exactly the kind of local opposition any democratic government has to actually listen to and accommodate. And it only pays off financially if prices stay high for the entire decade it takes to build and ramp up production. And China, sitting on the dominant share of global supply, could drop prices any time it wanted to, specifically timed to make a brand new Western refinery lose money right at the exact moment it needed profits most to survive. So which elected Western politician, facing re-election in 2 or 4 years, wants to spend $1 billion taxpayer dollars and a decade of hard-won permits on a chemical plant that a foreign competitor can bankrupt with a single well-timed price, cut the week it finally opens for business? Essentially none of them, at least not until very recently. So year after year, the politically and economically cheaper choice was simply to do nothing and keep buying from China at a discount nobody else could match. And while the West hesitated, China widened the reach of the same basic strategy into adjacent materials. It wasn't just rare earths anymore. On July 3, 2023, China announced new export controls on 2 metals most people have never heard of: gallium and germanium, materials essential to computer chips, fiber optics, and night vision equipment. With the controls taking effect that August 1st, requiring exporters to obtain a government license before shipping either material abroad. Each move was a probe, a test of how much the world actually depended on a given material, and how much economic pain Beijing could apply through nothing more dramatic than an export licensing form sitting on a desk. So let's put a number on how deep this dependence actually goes, because it's considerably worse than the earbud story alone suggested at the start of this video. Today, China refines around 91% of the world's rare earths, a figure tracked and published by international energy agencies monitoring critical mineral supply chains. It controls about 94% of the world's production of finished permanent magnets, up from roughly 50% just 2 decades ago, a doubling of market share achieved almost entirely through the patient price war this video has already walked through. And it isn't only these metals. China leads the refining of 19 out of 20 strategically important minerals tracked by international energy agencies, with an average global refining share of around 70% across that entire broader list of materials. Read those numbers again slowly, because they deserve a second look rather than a quick nod. This is not a country that got lucky with geology, sitting on some unusually generous deposit nobody else happened to have access to. Plenty of other countries have comparable reserves sitting untouched in the ground. This is a country that built the world's chemistry set, one patient decade at a time, and then quietly took the whole set home with it, while everyone else was busy admiring how cheap the results were. Evidência 3, 2025. A virada acontece à luz do dia. Which brings us to what just happened. For 15 years, the 2010 episode was treated as a one-off scare. In 2025, China stopped being subtle about it entirely. In April 2025, it imposed formal, publicly announced export controls on 7 of the heavy rare earth elements, dysprosium and terbium prominent among them, both essential to the highest performance magnets used in defense and electric vehicle applications. And, crucially, on the finished magnets made from them, not merely the raw unprocessed ore sitting in the ground. Not the mine, the refinery. The exact industrial step the rest of the world had spent 30 patient years quietly giving up, piece by piece, and therefore the exact step it couldn't simply replicate overnight, no matter how loudly anyone demanded it. Then, on October 9, 2025, Beijing went further still in a move that startled trade lawyers and export control specialists far more than it registered with the general public at the time. It added 5 more elements to the restricted list: holmium, erbium, thulium, europium, and ytterbium, plus lithium battery materials, and for the first time in the entire history of its export control system, asserted a genuinely novel kind of extraterritorial reach, sometimes described as China's own version of a 50% rule, echoing similar mechanisms the United States itself had long used to control American technology embedded in foreign-made products, requiring a Chinese export license for certain foreign-made products anywhere in the world, if those finished products contained enough Chinese-origin rare earth content. A factory in Germany or Ohio could, in theory, suddenly need Beijing's explicit permission just to ship its own finished product to its own customers. Here's where this part of the story gets genuinely fluid, and it's worth being precise about that rather than pretending otherwise, since a documentary account that claims more certainty than actually exists does its audience no favors. By the end of 2025, part of this October escalation had already been suspended as part of a broader trade truce negotiated between Washington and Beijing, one piece of a larger set of concessions traded in both directions between the two governments. This isn't a switch that got permanently thrown and stayed thrown in one fixed position. It's a switch that can be flipped, unflipped, and reconfigured depending on the state of a much larger, ongoing negotiation, which means the specific status of any one individual control, as of whenever you happen to be watching this, is genuinely worth checking for yourself rather than assuming it hasn't shifted again since this was written. What hasn't moved through all of this back-and-forth negotiation is the underlying April 2025 architecture restricting the finished magnets themselves, the core mechanism this entire video has been describing. That's the part that actually matters for understanding the real leverage at play here, regardless of which specific announcement happens to technically be in force on any given week. Sit with the scale of that leverage for a second, because the raw numbers are genuinely hard to hold in your head all at once. In 2024 alone, China exported around 58,000 tons of rare earth magnets to the rest of the world, a figure that translates into hundreds of millions of individual finished components scattered across car factories, wind farms, and electronics plants on every continent. Tonnage that factories everywhere had simply assumed would always show up on schedule, the way water shows up when you turn on a tap and never think twice about it. A meaningful, and at times uncertain share of those shipments now runs, at least potentially, through a permission slip signed by an official somewhere in Beijing. It's worth pausing here on exactly why the finished magnet, rather than the raw material, became the specific target of these controls, because that choice reveals just how precisely Chinese policymakers understand where the actual leverage sits in the supply chain. Restricting raw ore exports would have been a blunt, relatively easy to circumvent instrument. Buyers could simply source unprocessed material from other countries and ship it to a non-Chinese refinery instead, assuming one existed at sufficient scale, which, as this video has already established, it largely doesn't anywhere on Earth. Restricting the finished magnet instead targets the one step in the entire chain that genuinely cannot be replicated quickly anywhere else. It's the difference between blocking a country's access to flour and blocking its access to bread from the only bakery on the planet actually capable of producing it at industrial scale. One choice merely inconveniences you for a season. The other actually controls you indefinitely until you build your own bakery from scratch. Now, the obvious reaction, the one every Western politician had on camera the week these controls were announced, is, fine, then we'll just make our own. Dig up our own rock, reopen Mountain Pass, cut China out of the supply chain entirely, once and for all. And that reaction is exactly where almost everyone, including plenty of well-meaning politicians standing at podiums, gets the story wrong. Because it assumes the ore in the ground is the hard part of this whole equation. Remember the assumption I told you to hold on to back at the very beginning of this video, that if we ever truly needed these metals, we'd simply go dig them up ourselves, the way you might dig a new well when an old one runs dry. Here, finally, is exactly where that comfortable assumption falls apart completely. Here is the turn. The West did not lose these metals in a robbery. It gave them away, on purpose, over 30 years, one closed refinery at a time, because it wanted the cheap magnets without the toxic lakes. And that means the switch China holds isn't the rock in the ground. Remember, these metals aren't rare. America has plenty of ore. Brazil, Australia, Vietnam, all have plenty of ore. The thing the West gave away wasn't the mine. It was the refinery. The dirty, decades-deep, hard-won ability to turn rock into metal. Go back to that relief you felt earlier when I told you these metals aren't rare. That relief was the trap. Because if the bottleneck were the mine, you could fix it in a couple of years. Just dig a new hole. But the bottleneck is the refinery, and a refinery is knowledge plus permits, plus a decade plus a community that doesn't want a chemical plant next door. You can reopen a mine in 2 years, given enough capital and political will. You cannot rebuild 30 years of accumulated industrial chemistry in 2 years, no matter how much money any government throws at the problem, because the knowledge itself doesn't transfer through funding alone. It transfers through decades of trained engineers, refined processes, and institutional trial and error, most of which now exists almost exclusively inside Chinese companies and Chinese universities. And there's a real concrete and genuinely well-documented example of exactly how stubborn this specific gap turned out to be. In practice, sitting right inside the story of Mountain Pass's own attempted comeback. A company called MP Materials bought the shuttered Mountain Pass site out of Molycorp's bankruptcy proceedings in July 2017 for a relatively modest $20 million, a fraction of what the original modernization project had cost. By early 2018, the new owners had the site mining and processing raw ore again, and by late 2020, MP Materials had gone public, raising over $500 million from investors clearly betting on an American rare earth revival. That looked, from the outside and in most press coverage at the time, like the American mine was fully back in business. Here's the part that rarely makes the headlines. For years afterward, MP's concentrate wasn't actually refined in the United States at all. It was shipped to China, to a company called Chenghe, which held an exclusive processing arrangement and turned MP's raw material into the finished separated oxides America still couldn't produce for itself. The mine reopened in 2018. The refinery didn't meaningfully follow on American soil until January 2025, when MP finally began domestic processing of neodymium praseodymium oxide at a new facility in Fort Worth, Texas, nearly 7 full years after the mine itself came back online. Sit with that gap for a second, because it's the whole argument of this video compressed into one company's actual timeline. Reopening the hole in the ground took about a year. Rebuilding even one piece of the actual refining chain took the better part of a decade, and it only happened at all because of direct, deliberate government intervention. On July 10, 2025, the U.S. Department of Defense invested $400 million into MP Materials, becoming its largest single shareholder in the process. And just 5 days later, on July 15, Apple separately committed $500 million of its own toward securing a domestic magnet supply chain for its products. It took a mining company, a bankruptcy, a multi-year foreign processing arrangement with a Chinese buyer, the Pentagon, and one of the most valuable companies in the world, working in sequence over the better part of a decade, just to get one single facility partially back online, producing a fraction of what the country's own industry actually consumes. And we know this reflects a genuine structural bottleneck, rather than simply one company's specific struggle, because one entire country already tried to escape it at national scale, slowly, expensively, and only ever partially successfully. That country is Japan, and its experience over the following 15 years is, in many ways, the single most instructive part of this entire story. After 2010, Japan didn't just complain to diplomats and move on. It launched a genuinely serious 15-year plan running on 5 separate fronts simultaneously. Investing directly in a rival mine and refinery operation in Australia so it wouldn't have to depend entirely on Chinese processing capacity. Funding large-scale recycling programs to pull these same metals back out of old discarded electronics. Funding engineering research specifically aimed at redesigning products to use meaningfully less of the metal per unit. Actively hunting for chemical substitutes that could do at least part of the job with more available materials. And building substantial strategic stockpiles specifically to cushion against any future repeat of 2010. It worked, but only partly, and that partial success is itself the most important, most sobering data point in this entire story, more instructive in some ways than any single number that came before it. Japan cut its dependence on China from around 90% down to roughly 60% over that 15-year effort, spending real money and real political capital across multiple changes in government to sustain one consistent strategy that long. And it separately managed to roughly halve the total quantity of these metals its own industry needed in the first place, through the redesign and substitution work running in parallel the whole time. But look closely at that result, because it's the whole point this video has been building toward from the opening minute. It took Japan, a highly disciplined, well-funded, technologically sophisticated country that started working on the problem the very day it got burned, more than a decade of sustained, expensive, 5-front effort to move from 90% dependence down to 60, not down to 0, not even down to 30, down to 60. That is how deep this particular trap actually goes once you're inside it. That is how long it genuinely takes to climb even partway back out. And most of the West hasn't even started climbing with anything close to the seriousness Japan brought to the problem, let alone the seriousness it eventually took to get even one American facility partially back online, one government check at a time. So let's return to where we started. One country built an enormous patient industrial advantage in refining these metals through cost, policy, and decades of Western companies choosing the cheaper option. And the West, without ever quite deciding to, handed over the one step that actually mattered. We can now say exactly what that switch is. It isn't the ore under Chinese soil. It's the refinery inside Chinese borders and the 30 years of chemistry the rest of the world chose not to keep. The magnet in your earbuds is the smallest visible tip of it. None of this means the lights go out tomorrow, and it would be dishonest to end this video on pure alarm without acknowledging real, ongoing progress that's genuinely worth naming. The West is finally moving, and by 2026, that movement has real, measurable substance behind it, rather than just political speeches delivered for cameras. MP Materials' Fort Worth facility is now producing finished magnet-grade material domestically for the first time in decades, with direct backing from a Pentagon that became its largest shareholder specifically to make sure this particular project doesn't end the way Molycorp did a decade earlier under similar competitive pressure. Apple has committed its own capital toward the same goal from the demand side, betting that a secure, domestic, non-Chinese supply is worth paying a real premium for going forward. Elsewhere, other governments across Europe and Australia are funding their own versions of the same slow, expensive catch-up, each hoping, this time, to avoid becoming the next cautionary tale sitting in some future documentary. The switch is being copied, slowly and at enormous cost, by more than one country at once, each starting from a considerable disadvantage. But slowly is still the operative word here, and it's worth resisting the temptation to declare this problem solved simply because visible progress has finally begun after years of inaction. Every serious, independent estimate says the West remains years away from being able to produce these materials for itself at anywhere near the scale its own economy actually needs, not merely a symbolic fraction of it. For that entire remaining stretch of years, the switch stays mostly, though no longer exclusively, in one hand. And, as we've just seen, that hand can tighten or loosen its grip depending entirely on the state of a much larger trade negotiation, which means this is a situation genuinely worth continuing to watch, rather than one you can safely file away as settled and move on from. And there's a lesson here that's bigger than metals, bigger than any single supply chain. It's about what a rich society quietly gives away, almost without noticing at the time, when it chases the cheapest possible version of everything it consumes. For 30 years, offshoring the dirty, unglamorous, low-margin work looked like pure genius from every angle anyone bothered to examine. Cleaner air at home, cheaper goods on every shelf, higher corporate profits, quarter after quarter. Nobody paused long enough to notice that the boring step, the refining, the actual making of the thing, was the part that quietly held the real, durable power the entire time. The West kept the elegant design and the recognizable brand. It gave away the underlying ability to actually make the thing with its own hands. And it turns out, after everything this video has walked through, that the ability to make the thing was the thing that actually mattered all along. So the next time you pop in your earbuds, or drive past a wind turbine turning slowly on a distant ridge, or read a headline about a trade fight you don't quite follow closely enough to fully understand, you'll know exactly what's sitting underneath it, quietly doing the work. A gray magnet the size of a paperclip. A phrase from 1992 that sounds considerably more prophetic in hindsight than the historical record actually supports. and a switch that one country spent decades patiently learning to build and hold, while everyone else on Earth was busy simply enjoying the discount it offered along the way. There's a specific kind of patience embedded in this whole story worth sitting with one last time before we close. Rebuilding even one American facility, from a shuttered mine to a partially functioning refinery, took the better part of a decade, a bankruptcy, a foreign processing arrangement, and direct intervention from both the Pentagon and one of the most valuable companies on Earth. Whatever else you conclude about how this specific situation developed, it's worth acknowledging just how much sustained effort it now takes to claw back even a fraction of an industrial capability that took 30 patient years to lose in the first place. But rare earths are only the first of these switches. Because while the world was arguing about magnets, the same country was quietly building the exact same kind of leverage over two other materials most people have never heard of: gallium and germanium, the metals sitting inside every advanced computer chip on Earth. That's the next story in this series. And once you've seen the pattern here, you won't be able to unsee it there. There's something worth carrying forward beyond the specific numbers and dates this video has walked through. Every one of the decisions that built this dependency, taken on its own, made perfect short-term sense to whoever was making it at the time. No single closed refinery, no single bankruptcy, no single choice to buy the cheaper import instead of funding the expensive domestic alternative looked like a mistake in the moment it was made. It's only when you step back and look at 30 years of those individually reasonable decisions stacked on top of each other that the shape of what actually happened becomes clear. That's worth remembering the next time some other seemingly small, seemingly sensible cost-saving decision gets made quietly, somewhere else entirely, about some other material nobody's paying attention to yet. If you want to follow the map of how modern power actually works, the quiet switches under the headlines, this is what this channel does. I'll see you in the next one.